Awesome. All right. So I think we're live. Let me check on my phone. Yes, we are. Awesome. Yeah. So maybe we give it like a few minutes to start to wait for people to join. Nice. Now you put the privacy. Yeah, I have that one too.
Nice. Where'd you procure your privacy cap?
I think it was at probably what like one of the first convention I went, like the one in Toronto last year. Actually, it was the first. Yeah,
Oh, awesome.
if Toronto, really nice
Nice.
convention.
Yeah, I don't even think we had IBC hooks working yet then with VRF.
No, probably not yet. It's pretty new. It's pretty
Yeah.
new, even for you guys. Yeah,
Wow. Yeah, so much has changed in a year.
yeah. The I mean, goes fast. That is the nature of blockchain. I feel like in the Cosmos ecosystem, it's even faster. It's crazy.
Hmm.
All right. So hey guys, Coreum all the way, Secret all the way as well. Shout out to the Secret Network. Yes, yes. Thank you for joining today, Sean. That's really appreciate it. Okay, so yeah, let's start, guys. So today we're here for a new technical workshop, and we're gonna talk about Coreum V4. So we did a poll. So Coreum V4 came with a lot of new features, right? And we did a poll. What new features would you guys want to see first? And it came to smart token extension and IBC hooks. So this workshop is toward those two new functionalities that are coming with Coreum V4. And we have, as you can see, a special guest from Secret that is going to tell us about Secret VF4 and verifiable and the randomness, their randomness model. So yeah, Sean, if you want to present yourself and the Secret network.
Sure. Yeah, let's do a quick intro. Thanks so much for having me. Hey, everybody. My name is Sean Conrad, and I do DevRel for Secret Network Foundation. So my kind of journey into the Cosmos was I started in the EVM and then started working with privacy tech, and then slowly just kind of found my way to Secret and learned about Rust and Cosmwasm and all these wonderful things, and then just fell headfirst into the Cosmos because of this. So I've been with Secret Network for about 2 years now, and in that short amount of time, I've just seen so much growth. Like we were just saying at the top of this call, we didn't even have IBC hooks a year ago. So the sorts of things you're able to do now as a developer building in the Cosmos is just like tremendous. And I'm excited to be here today and just see what you guys have built with VRF and Secret and Coreum.
Yeah, actually, you haven't seen it yet, right?
No, yeah.
It's gonna be a discovery even for you. But I did use some of the contract you actually wrote on the secret side, so that's perfect that you're here. Okay, so first of all, what is Coreum before? What are smart tokens? And then from there we can go to what are smart token extension and then IBC hooks. So smart tokens are assets that live at the protocol levels, and what is cool with them is that they come with a set of behaviors that are deterministic, like whitelisting, freezing, burning, and others. So you can think about those tokens like fungible tokens. They came with fungible and non fungible, but today we're gonna focus on the fungible part of it. So they come with a set of features. They're deterministic, and the gas that they use is deterministic. Um, we did on actually Tuesday. It went live on mainnet, the Coreum V4 upgrade, and it came with smart token extension. So what are smart token extension? It's something that I like to say make those tokens even smarter because you're able to attach a smart contract to those smart tokens. So every time you send the token or you do any type of action with the token, you're able to trigger a smart contract that is going to extend the behavior of the smart tokens. We'll jump into it later on. And the other topic of today is IBC hooks. So IBC hooks are it's actually middleware that enable ICS20 token to trigger a smart contract to how can I put it? By placing some information on the memo, when the token goes from one chain to another chain, you're able to trigger a smart contract and pass different parameters that were in that memo. Um, do I've got that word, Sean? Do you have
Yeah,
the
that's
same
exactly right.
understanding?
Yeah, so it just kind of opens up all new kinds of exciting use cases with possible with token transfers.
Yeah, definitely, definitely. So those are the two new models we're going to tackle today, and of course, secret VF4. So can you tell us a little bit more about this tech, Sean?
Yes, so Secret Network is it's a L1 privacy chain in the Cosmos, and we now have expanded support also to EVM and to Solana with using ECDH cryptography. But natively in the Cosmos, you can receive randomness from Secret over IBC, and now even easier with IBC hooks. So Secret, everything that happens on Secret Network happens inside of a trusted execution environment. Maybe if anyone who's here has been kind of bopping around Web3 Twitter space in the past few weeks, there's been a lot of talk of TEEs in the privacy landscape. So Secret was one of the first L1s to actually adopt this and make this the basis of everything that happens on our chain. So you can kind of think of Secret as just like a black box where all of your contract executions happen, and inside of this black box, everything remains private. You only reveal what you want to be public on chain. And so part of this, what we're able to do is inside of this trusted execution environment is generate verifiable random numbers. So that's what VRF is, verifiable random functions on Secret Network. And now what we can do is generate these random numbers and then be able to pass them to other chains with IBC.
Nice, very nice. And so that people very well understand like how cool it is it's really because of the nature of blockchain. It's deterministic, everything is public, so that's why it's really nice to have a module like the one you have to actually have randomness that can be trusted and truly random.
Exactly. Yep.
All right. So I'm gonna share my screen and show you the use case that we actually did build with those three features. So we try to do something that makes sense and that at the same time is using those three different techs, right? So smart token extension, IBC hooks, and secret network VF4. So let's jump into it. So the way we're going to proceed is actually I'm going to show you what the workshop looks like, the end product. Then I'm going to show you a context diagram that explains what is actually happening on a very high level. And then we're going to jump into the actual code. So we're not going to code everything from scratch. It will take too much time. But the GitHub repository is actually available. Maybe we can put it in the on Twitter, like pin it near the tweet, so like these people can see it and follow along. And then we'll finish with a set of questions. All right, so my screen is shared already. Okay, perfect. So the application we choose to build is a decentralized application. Of course, that is a flip the coin game. So flip the coin, it's really easy. Everyone knows about it, right? Head, tail, you bet on one of the two. And then depending on your luck, you win or you lose, right? But on the blockchain, how can you actually generate that randomness, right? How can you simulate the you throwing the coin like you will do in real life? There is no air on the blockchain. There is no all of that kind of entropy. So you need a way to generate randomness, and that is done thanks to secret network VF4. Okay, so let's look at it really quickly. Let's try it, and then we'll jump to the context diagram. Okay, so we have the user interface right here, the game, the results. You can see add, tail, unique ID right here, and the ID that is interesting right here that says smart token extension. So we will explain actually right now why is that those ideas are different. Okay, so let's try to flip the coin. So I click on flip the coin is flipping. Then I have this message that is popping right here. Like I need to sign a transaction with that parameter. I call this function with that parameter. So the job ID right here that is generated in the front end. I click approve. Then I receive the transaction hash from me calling the contract. And then right now I'm waiting for the IBC response. So that can take some time depending on how fast the relayers are picking the transaction. Maybe Shen, you can explain what are relayers and how do they fit into the IBC landscape.
Sure. Well, so for anyone who hasn't worked with IBC before, there's just very specific language in which you have to write code to be able to communicate with it. But basically, the way this works is there's two contracts that are existing and they're in communication with each other. There's a contract on the consumer side on Coreum, and then there's a secret network contract. And so what's happening here is the Coreum contract has to, when we execute that contract, it's sending an IBC message across the cosmos to the secret contract, where it's then requesting verifiable randomness from the secret contract. So the secret contract then generates that randomness inside of the trusted execution environment and then sends it back to the Coreum contract. And the way that works is just using just this like boilerplate IBC language. And it all happens with like a Cosmos message, a Stargate message that initializes the serialized IBC transfer. But in the meantime, while those relayers pick up that information, that's why it could take a little bit of time.
Awesome. Exactly. So everything that Sean said did happen when you saw like me flipping the coin. You saw that the result that just came. So we can see the result right here with the same job ID that we just signed. And he left Coreum, went to Secret Network, and came back. So that was the first path, right? And that include IBC hooks and Secret Network VA4. But what about Smart Token extension? So I can open my Leap wallet. Shout out to Leap, by the way. Then I can see that I have some flip tokens, right? So, whoa, what are those tokens? Let's see what they can do. So I'm right here. I'm going to try to send, let's say, one flip to this wallet address right here. I review and I send it. Awesome. So what is happening in the background is that this token is being sent from one wallet to another, but by being sent, it actually trigger the smart contract that is going to do the whole mechanics that Sean just explained. So let's wait a little bit, and I'm not touching to anything. We should see the coin flipping by himself. Exactly, perfect. Oh, that was a fast one. So we can see that it's tail. So let's wait a little bit. Up, tail. And when we look at the result, we see that it was actually a smart token extension that triggered that smart contract because we have the job ID right here. Okay, awesome. So hopefully everyone is excited for that workshop. One of the workshop that I enjoyed doing the most was really fun. So hopefully you guys liked it as well. Okay, so this is the context diagram that I talked to you about. So we have the browser, right? So I'm using Chrome. We have the CoinFlip decentralized application, and we have the Leap wallet. That is, let's say, what is on the client side on my machine. Then we have the Coreum blockchain, which have a WASM VM, and we have the smart tokens module. On the secret network blockchain, we have also a WASM VM. And as Sean said, we have the random number generator contract that is calling their VF4 module. So let's look at the two different paths that I just showed you within the application. when I clicked on flip the coin and when I sent the um, the flip token to another wallet. So we have the coin flip application right here and the Leap wallet. So I click on flip the coin. Leap wallet is asking me to sign the transaction that was generated by this app. Then Leap wallet is propagating that transaction to the Coreum blockchain. And after that, uh, the flip the coin contract on Coreum is uh, get triggered with the parameter and the job ID. That is a job ID. There is only one parameter. It call the secret network contract by sending an IBC message, which is an IBC hook message with the right parameters. The secret network contract requests the randomness from the right module, the VF4 module, send it back to the secret network contract. Then the secret network contract is also doing an IBC hook, but this time from secret network to Coreum. So it's sending an IBC transfer message with the contract address on Coreum and the right parameters. The contract on Coreum is processing the information and sending back to the coin flip application. That is the first, let's say, way of doing things. The second way, by sending the flip tokens, we actually just send the token, and this token is triggering the smart token module. And the smart token module is the one doing the call to the coin flip smart contract. So hopefully you have a better understanding of, on high level, what is happening. Then I think right now we can actually go into the code and see what is happening on a technical level. Okay, perfect. Okay, so let's jump straight into the code right here. So as Sean was saying, we have two contracts, right? We have the one on Coreum and the one on Secret Network. So let's start with the one on Secret Network and see what is actually happening in that contract. So maybe Sean, you can start by, I think you wrote that contract, so you can start by explaining the different entry points and different functions.
Okay, yeah. So this was created by Alex Saturn, who's another DevRel for Secret and just also a Chad developer himself in his own right, and myself. But Alex had this idea where before IBC hooks, we were receiving randomness via IBC with like 3 different smart contracts. It was just this really complicated mess. We got it to work on Juno, but once IBC hooks came out, we wanted to simplify things. And so Alex came up with this design schema, and basically all that this contract is doing is just doing 3 things really, which is it's extracting the information. So it takes the information that's passed from the contract on the consumer chain, in this instance Coreum, and then generates these random numbers, and then it signs the random numbers. So another piece of this contract is signature verification. So I think you'll see, I think it's in the instantiate message, that we generate a key pair. If you look in the instantiate message.
Yes, right here.
Yep. So all that that's doing is just creating a public and a private key pair for this smart contract, so that then we can verify that these numbers are not tampered when we actually send them from Secret back to Coreum. And so, yeah, so really all that it's doing is, firstly, it extracts the information. So like, as you were saying, there's the job ID that you pass, the number of random numbers to generate, and also the IBC channel to send the response back to. So that's the information that's extracted. If all that sounds good, it then generates the random numbers from the current block. So if you go to the randomness function.
Yeah, let's do it.
Yeah.
So I execute this one, right?
Yep. And if you zoom in, you should see like inv.random, which is where the randomness is actually being generated.
Right here, line 9,
Yep.
5.
Exactly. So what's actually happening in real time right here is that that env parameter is short for environment. And so it's taking from the block environment, that block is where it's actually taking the random number and then using that as the seed to generate what the random numbers are that we pass back to Coreum. So that's the generation of the random numbers piece. And then encodes the random numbers in a base64 format to prepare for the transfer. It then signs in that function, it signs and says, using its private key, and says, this is legit. This is coming from me, this smart contract. And then the other smart contract, it has the public key from this contract so that it's able to verify that it actually did in fact come from this contract and from nobody else. And then from there, if it's successful, we have this basic IBC language where we can either have it's called an IBC ACK, which is an acknowledgement, or a timeout, an IBC timeout if it's not successful. And that's all, it goes through all those steps just with that one function call.
Nice. So I think that what is the most important right here is actually this part, right? That is getting as you said, like the random seed from the node directly.
Yep.
Nice. Very nice.
Yeah. So it's so cool. It's like in real time, it's taking it from the block on secret network. And then now we have this kind of elegant way where with IBC hooks and through your smart tokens, we're able to just send it right back all in the click of a button.
Yeah, it's really awesome. And I think that is of course, it's a custom module that you did build, right? It's it's this one, right? From Secret Toolkit.
Yes. Yeah, I think it actually comes from the if you go to the Cargo Tomo, I think it's like secret storage is part of what the imports are. Is that right? I think it might just be at this certain Cosmwasm STD version that allows this to happen.
Probably. I remember I saw it somewhere. Or maybe, I'm not sure. But it's definitely like from a custom module that you guys build, but the query in the secret network. Yeah, maybe it's just querying directly the blocks, right? Without any custom message.
Yeah, and all this is in our docs too. So if you just Google Secret Network docs, you'll be able to do this exact same thing, except for they won't have the beautiful 3JS element that you have there for the UI.
Yeah, that is a Coreum customization. All right. So okay, awesome. So that is that contract, and actually, this contract is, as you mentioned, is available on GitHub. It's public, and there is a tutorial very well made that is coming with this contract that explains in details what is happening. But you just got an explanation in live, which is even better. Okay, so this is the smart contract on the secret network. Let's jump and see what we have on Coreum. So we have this public key, right? The one that is making sure that the message was signed by the correct private key. So the one that is on the on secret network smart contract. Here we have the channels. So the IBC channels. So the channel on the secret network is 101 and the one on Coreum is 25. And the reason for that is because the contract need to know from the channel that it need to use to send the message. And those messages are being watched by the relayers that are going to pick it from one chain to another chain. Okay. What is interesting here is that we have in the instant chat message, we have an array of jobs. So if we look really quickly at what are the jobs, so job is really simple. It has an ID, which is a string, the randomness, and the result. Really simple. And then we have jobs, which is an array, a vector of this structure right here. So we pack multiple jobs into this state right here. Okay, so we instantiate the contract, nothing crazy right here. Let's actually look at the different uh, entry points. So we will see that we have 4 entry points in this contract. We have the instantiate, the query entry point, the execute, and a pseudo entry point that is related to smart token extension. Okay, so in queries we have one message that allow the DApp to actually get all jobs. So this query is going to call that function query all jobs. Let's look at it real quick. So we just get all the jobs from the state I just showed you. We iter around them, we collect them, and we parse them into binary and send them back. So really simple. We just query all the jobs and return them into binary form. All right. The sequence query is the same, but to get one job ID. So here it is. So we have to iter all around within the whole vector to find the job ID that we actually need. Maybe with a map, it would have been faster to actually, with a key, to get the job ID by its key. But with that implementation, we have to go over the whole vector. Okay, so queries are functions that actually do not change the state of the contract. Then you have the execute function. Those are the ones that actually change the state of the contract, and they are right here. So we have two different execute functions. We have request random and receive random. So let's look at request random. So request random is actually just packaging the information that we want to send to the secret network into that IBC hook memo. So you can see that right here we have the contract, we have the message that is going to be request random, the job ID, the number of words that we did outcord to 1, and that's pretty much it. The secret network contract address and the channel ID. Then here what we have is actually an interesting mechanism is to look if we have some funds that are attached to that request. When the UI is calling, the wallet is calling the request random, some funds need to be attached to it in order for the IBC hook message to be sent. So IBC hooks, it's a memo that is attached to the ICS20 token that is sent from A to B. So it needs to be a token that is actually sent that we're going to attach this message to. So here, if the funds that are sent are empty, and I will explain why this can happen, we actually use some funds that are from the contract. We use one new core, so a very small amount, and attach it to that message. If there is some funds available, we use the funds that are coming from the request. And here we have this target message that is actually gonna trigger the chain and send that IBC hook message. Sean, if you want to add something, because you actually and Saturn wrote that part, feel free to do so, right? Anytime.
Okay. Just that, yeah, so we have this Stargate message that we hard code into the contract. And I don't know if you ended up using this in your development as well, but we have we wrote a JavaScript function to actually be able to request the randomness.
No, actually, I'm not using it, but I think I've seen it. I don't know if you've taken the contract in the code base, but I've seen it.
Awesome.
So it's actually what we're doing with the DApp, right? But directly within a JavaScript file, right?
Mm-hmm.
Okay, awesome. So this is how we request random, right? And then let's jump straight to the receive random. So how do we receive random? So this is the IBC, the function that is going to send the IBC message from Coreum to secret. And then we need a function that is going to receive the IBC message from secret to Coreum. So let's look at it. This function is called receive random. And what we do is get all information from the response right here. So we have the action, receive random, the job ID, the randomness, and the signature. I end up not using the signature actually, but we still have it in that message right here. So the most important part right here is that we get the randomness right here, and we read it as an int 32. If that number is a modulo of 2, it means that it's L. If not, if it's different than 2, then a modulo of 2, it's tail. All right. So let's say if it's 10, then it's add. If it's 11, it's going to be tail, and so on. And then we just save the job ID. Actually, here we load the jobs, right? We create this new job with the result and the randomness, and we add it into our job state. And that's pretty much it. Okay, so from here we did cover everything that goes from, I'll share my diagram once again. So we cover everything that happened here. So we did first this right here, and we just finished this part right here. So now, smart token extension. So how can you actually trigger that smart contract? By sending a token from your wallet. Pretty amazing. So the way you will do it is by adding to this contract a pseudo entry point right here. And pseudo entry point is an entry point from the CosmWasm contract that can only be called by trusted Cosmos SDK modules, just like the bank modules. So it means that this right here, this function is going to be called when the send is being made. So let's look at what we have in it. So we have all of those different parameters: the sender, the recipient, the transfer amount, commission amount, burn amount, and a context. Let's look at what's happening in this function. So when this function is being triggered, we call the same request random function, but this time we pass it the job ID smart token extension. We hardcode it, so we know it's coming from that exact function. So let's get back to the DApp real quick, and let's look at the result. So smart token extension right here, smart token extension. Let's try to do it again, see if we can have head, select the wallet, with the transfer, send. Okay, so let's look at main scan and see what happened. So this is our contract. This is a contract address. It's loading. Okay, so we can see that we have this send right here. So I did send one flip token to this other address, which is not the smart contract address, right? It's another EOA account. It's just another wallet address. And from here, we should be able to see that we're gonna get an IBC receive because it did trigger the contract and go to that whole flow that we just explained. can take some time depending on how fast the relayer pick up the transaction. Okay, so maybe we get back to it when it's actually gonna get here. Okay, so now what I what we can do is look at the actual front end, and we will create our own smart token, right, with the core DCLI, and instantiate our this contract, and we will plug it into the user interface, so into our front end. Okay, so we were here. We did this one on the secret network. We did that one on Coreum right here, which is this one. Let's close it. And now what we can look at is this Next.js application, which is this, right? Okay, so let's look at that application right here. So those are the different folders that you have, but the one that is interesting is the source folder, where we have actually the code for the user interface. Okay, so let's go directly to the index.tsx, which is our main page. And the first thing that we can notice right here, let me see. Let's go. Okay, so this is the actual HTML that is being rendered. So that is the Canva, right? So this is the coin that you're seeing on the website as a reference. So this right here is actually that coin right here. Okay. Then we have the game button, right? So to switch to game, from result to game, we have the Canva. We have the list of results when the result button is being clicked. We have the result button to go to the result page, right? And we have the flip the coin button. So the UI itself is really minimalistic, right? There is not that much stuff. So the game button, the result button, and the list. Okay, so now let's look at some of the code that is being triggered when you click on those buttons. Okay, so the first button that we're going to look at is the flip the coin button, the one that you actually press. So what is here is that when we click on flip the coin, we attach one new core to the message that we're gonna send. Let's see what is this message about. So this message right here, it's this one. So we request random with a job ID, the fees, and the funds, right? So the funds are right here and the fees are right here. So let's see what is request random. It's right here. It's an execute message that takes the sender, so the wallet that is connected to the application, the contract address, the function that we want to call, the request random, the one we looked at into the contract, pass the job ID, the fees, a memo, and the funds right here. Okay, so that is what is going to be triggered when we click on the flip the coin button. So let's look at it right here. Or maybe something I forgot to mention is the job ID. How do we generate the job ID? So the job ID is actually UUID, right? So it's a random number, actually a random hexadecimal that is being generated by the application. So it can be, we will see what it looks like, but it's totally random. Okay, so flip the coin, that is the button we looked at. Those are the parameters, right? So the amount when you core, the message right here, the job ID that was generated randomly. So this one is 25580 and so on, and the sender, which is my wallet address that is connected to the application. All right, let's close this one. I think we just received the smart token extension right here. Okay, so we have the UI. Maybe we can look at the way how the coin is flipping, right? So the coin we made it in Blender, so it's just it's a static file, but with a library that is called 3GS, you're able to animate it. So when the coin is being flipped, we call that function that is named trigger flip animation. Actually, it's this one, trigger flip animation from UI. And through different states, we are able to say, okay, this is the up position, this is the down position, and you need to send the coin to the up position when the button is clicked. Then you need to send the coin to the down position when you receive the first message that is telling you that the contract has been executed. And when we receive the IBC message, right here, we actually want to stop the coin from moving right here. And we want to set the coin in the right position depending of the flip result, right? So if the flip result is head, we're going to show the face of the coin, and if it's tail, we're going to show the other side of the coin, right? Okay, something that is interesting to notice, and then we're going to move on from the UI, is that we have a contract address right here, right? So how do we get that contract address? The contract address that we actually are querying when we click the flip the coin button. And this is what we're going to do now. Generate that contract address. Okay, so let's do it. And then when we have our new contract address, we will replace that contract address with the newly created one. Okay, so I'm in my terminal right here. So on the left, actually, let me check that I'm not speaking for the last, I don't know, 30 minutes or nothing.
Sounds good.
Yeah, okay. This happened to me once. Okay. So yeah, so let's create the smart token that is going to instantiate our smart contract with the smart token extension. But first, do we have any question? I mean, Sean, do you have any question? Maybe is there any question in the chat? Let's look at it. Live studio.
Somebody asked about which upgrade takes you guys to the next level. Because you were right now, this is all happening on testnet, but you guys don't have IBC hooks on mainnet yet, right?
No, we do actually. Yeah,
awesome.
we do have IBC hooks on mainnet. It went on mainnet actually Tuesday.
Oh, nice.
Yeah. That's a good question actually. So those new function IBC hooks and smart token extension, they went live on Tuesday.
Incredible. Yeah. And yeah, so for anyone who's listening too, because this probably could feel kind of intense, but like a lot of what you're saying, so much of this contract, it's all set up so that anyone who's watching this right now has all the tools they need to just deploy this themselves right out the box. All the work's already been done. And also something that I just want to share that's kind of cool is everything's happening here with IBC hooks with verifiable randomness. We've also just finished developing with one of our community developers, a guy named Cromston, a very talented community dev. doing the same thing but with encryption for smart contracts. So any sort of application that developers on Coreum would want to make that want to have private data, they can now do that as well with IBC hooks. So if there's like a private voting application or like a application where people want to keep their bids private for like a sealed bid auction or private messages being sent, any sort of application that needs this, we've just created this tooling with IBC hooks. So I would love to share this with you after this, perhaps, so that maybe we can do like a future developer workshop.
Yeah, definitely, 100%.
Cool.
So yeah, actually that would be amazing, because this right now we are showing a flip the coin, but the possibilities are endless, right? There is so much application that need randomness,
Yep.
um, which is, as you said, like voting. Uh, what
Yeah.
else could need randomness, like in a real world use case?
Any sort of gaming application. We've seen lots of games on Secret that have been being built with VRF. But yeah, randomness, and now we also have encryption that can be
Encryption, yeah.
yeah. And so that's like the next stage for us. And the other thing I wanted to say, this application you built, it's an amazing full stack application, and we've been doing these quarterly hackathons for developers where we have every time we have a cross chain track, so developers can submit as long as their application uses like IBC and another chain. So like we just completed this round of hackathons. We're going to have another one in the fall. But like if anyone who's watching this, if you built an application similar to exactly like what you built here, it would be a very competitive application in the hackathon. And
Nice.
and we're just excited to see other chains using our tech. And this is like, to me, like the perfect example of how you could use randomness on Coreum and build an application. So to anyone who's listening, there's prizes to be won. And there's like real world use cases for what you're seeing today.
Nice. Yeah, I might submit this application.
Yeah, there you go.
Improve it a little bit and submit it.
Yeah.
But yeah, it's amazing what you can do, like with this type of technology. And when you actually like merge them, right? It's even better. Okay, so that was a little break. Let's jump into the last part, which is issuing the smart token with the extension. Okay, so I'm gonna go to the documentation right here. Yes, actually, no, I'm not sharing my screen, right?
Not yet.
There. Okay. Okay, awesome. Let me know when you can see it.
There we go.
Amazing. Okay, so right now I'm on the doc website, and this is just a little uh, advertisement to our last documentation website. We did just upgrade it actually last month, and so this is what it looks like. So my screen is pretty big, so usually it's a little more. I think it looks better on small screen, but whatever. So this is the documentation website, and you have actually this plugin, which is a AI plugin that enable you to ask anything you want about Coreum, and you can highlight some part of the doc, and it will give you a really detailed answer on what you are actually highlighting. And there is more to come. Okay, so in the modules right here, let's look at smart token extension. Actually, let's go directly into how can we issue those tokens with the CLI. Okay, so we see that we need to do Cordy from the transaction module, then use the AssetFT module, issue, choose a symbol, a subunit, a precision, an initial amount for a coin, a description, a URI if you want it, if you want to add one, URI hash from the wallet that you are actually deploying this token, and choose the list of features. So I was talking about smart token earlier and their different deterministic behaviors. So those are some of them. So burning, freezing, minting, whitelisting, and now we have extension. So those features, what is really nice about them is that, as you can see right here, you can choose to enable them or not. So you can create the coin that is really tailored to your use case. And even more right now with smart token extension. So let's switch back to the terminal and issue our smart token extension. So CoreD, so I just have a different name for the binary right here, but it's the exact same binary. And after that, actually, let me copy paste this because I think it's gonna be faster. Okay. All right, so let's start from the beginning. So symbol, let's say we want to call it the, let's say, workshop token. Then subunit, let's say, is going to be work. I want a precision of, let's say, I want to use 0 this right now because it's also a thing that we implemented into the Coreum v4. You can choose precision 0. So what is precision is the smaller amount, smaller unit of the coin. So let's say for the Coreum coin, for example, it's 6. So 1 Coreum is equal 1 million, not 1 million, it's 10 power 6 U test U about, yeah, 1 core, sorry, is equal 10 power 6 U core. So that is how you actually set the precision. So let's put 0 right here. Initial amount, I will say 1000. Description, let's say this is the workshop token. URI, we not gonna put one, URI hash neither, and from my wallet. So my wallet is called the dev wallet. And then the different functions, right? So burning, we don't want burning. Freezing, we don't want freezing. We will keep minting in case we want to issue more tokens from the initial supply. So let's say you want to mint another 1,000 of those tokens. Whitelisting, we're going to disable it, and we're going to add extension. Burn rate, we put 0. The one with burn rate. Commission rate, 0. So burn rate is how many tokens are burned every time there is a send, right? Commission rate, what is the commission that the issuer is taking every time there is a send? So this is 0, right? And the code ID extension. So the code ID extension is actually the ID of our smart contract on chain. And that made me think that I forgot to actually store the smart contract to get that ID. So let's finish with this and let's store the smart contract really quickly so we can get that code ID. Extortion funds. So those are the funds that are going to be attached to the smart contract. So we're going to put 1 U test core right here, and that's it. So we don't have the extension code ID, and this is because we did not deploy our smart contract yet. So let's deploy the smart contract. Okay, so we have the wasm file here. So I did build the contract and put the file, the output file right here. And let's store the contract. So I have different pre-built message right here. So I'll just store it with one message that I have right here. Okay. From dev wallet, we will use the test wallet. The chain ID is not Coreum mainnet one anymore. It's going to be Coreum testnet. And the node is going to be the testnet one as well. Okay, let's see. All right, so this is the, I believe it's base 64 representation of the contract. Let's say yes. And now we have that transaction hash. So let's look at it right here. Okay. Okay, successful. And we have the code ID. So the code ID, there is 3 steps in deploying a contract, right? You have to actually build your contract. So that gives you a .wasm file. After that, you have to store it, so put it on the chain. And then you have to instantiate this contract. So from the code that is being stored, you have to, what is synonym of instantiate? that's a good question. You have to initialize your contract. And yeah, so you can instantiate many contracts from the same store code, let's say. Okay, so we have our code ID. Good. Then what is going to be next is, let me clear this. Okay, what is going to be next is to deploy our collection. Issue. So this is the message to actually issue our smart token with our extension. So the code ID is 1668. And after that, I think this is good. I might gonna need to put the node up. What is going on? Okay, we're missing something right here. No matches. Oh yeah, this we can delete. Let's try again. Okay, so this is not the actual endpoints that I want. So let's do this real quick. Okay. All right. All right, so it's asking me, do I want to broadcast that transaction? I'm gonna make sure it's on testnet, test core, 1000. All right, the funds are gonna be attached to the contract. Let's say yes. Transaction hash. Let's refresh here. Okay. Not yet. So what is happening actually here is that our smart tokens is going to instantiate our smart contract. So it's going to be the admin of this smart contract. So let's see if we have it now. Okay. Okay, so we out of gas, gas used, gas wanted. So it means that there is not enough gas to complete that transaction. So I think there is a parameter that this gas, and could put it in auto maybe. Let's try again. Okay, here it is. It's still out of gas, so I think but it's closer. So I think we need to tell him um, to multiply the gas. I think that there is a parameter for this. What is it? Yeah, gas adjustment. Okay, let's try again with the gas adjustment of 1.3. Yes. Let's wait for transaction to appear here. So when this is going to work, and it's going to work, we're going to have our smart token that is going to be created. So it's going to look like this, right? So I'm going to be able to see it in my wallet. Probably not because this one is going to be on testnet, but it's going to be just like any other coins, right? But it's going to manage the smart contract that we just looked at together. So let's see if it worked. This one should be the good one. Yeah. Okay. Perfect. So we can see that we have our token right here. The subnet is work. The symbol is workshop, just like planned. The description right here. The initial amount, which is 1,000. Burn rate, commission rate 0. And the code ID is the good one. Perfect. And I think we can look a little bit more in depth if I find it right here. I think we're going to see the smart contract address. Perfect. So this is the smart contract address that has been initialized when I issue the coin. You see instant sheet. Perfect. And the owner is my dev wallet right here. Perfect. So now let's actually look at this smart contract. So I'm going to copy it, paste it into the Explorer. Make sure to do this. Okay, so I have the smart contract. The coin is issued, and I can actually, if I want, go back here and plug the smart contract address right here. I think I just need to go in the config and put Coreum testnet right here for the wallet. Let's do, let's run this. Okay. Okay. Perfect. So we can see now that we are on testnet, right? And if we look at the results, there is no result yet because nothing happened. So let's try to send this token to another wallet. And this time we're going to do it instead of doing directly from the Leap wallet, we're going to do it from the CLI. Perfect. So what I will need from this right here to do the send, I need the denom of my token. So let's go here. I'm going to go to the Explorer.
I need to jump off in just a sec.
Oh, really? Is it better right now?
No, just for time. I have to get off the call in just a sec, but it's looking great.
Okay, Ocean. Thank you so much for joining. Really appreciate it. Actually, let me put back the camera.
There was one question somebody asked. Could they use this to generate random tag IDs for their fashion item in their contract? And I think that should be totally possible using this.
Nice. Yeah, I think sky is the limit. Honestly, when it comes to what you can do with those type of things, it's really amazing. But Chen, thank you so much for joining. And if you guys have some questions for Chen, feel free to either drop them in Twitter or send them in our Discord, and we'll make sure to send it to Sean.
Yes, and that's awesome to hear that you first got your secret hat in Toronto last year. We have another event if you're going to be in Toronto again this year
Nice.
for the Futurist Conference on August 13th. So it's DCC
Yeah,
Day.
probably gonna be there.
You will be?
Yeah, probably. Yeah.
Okay, awesome. Yeah, so if you come by the DCC Day, the Decentralized Computation Day, it's on August 13th, and I think it's like a couple hour event. But yeah, definitely come through. Get another privacy cap.
Nice, nice. Yeah, hopefully
Yeah,
you guys have some new goodies then. Like
yeah,
you have some good goodies. I actually the flip the game. If you want the backstory, I did it because you guys have a coin, like a physical coin that you give. I think it has the secret logo on it, and
oh yes,
there is something on it. And I was playing with it, and while playing with it, I was like, oh, that is actually what can be done on chain.
that's awesome.
So it's all because of the goodies. But yeah, let's do this again, and thanks again for joining, man.
Yeah, thanks so much for having me. It's just really cool to see what you've been able to build out. So yeah, just keep it up, and yeah, definitely we can do another one for encryption.
Yeah, let's do it. Definitely, let's do it. I
All
think
right, thanks
you want
everybody.
to
Thank
love
you
it.
for
All right, see you, man.